Welcome students to another lecture on orthographic projections. In this lecture we will take first problem and we will learn how to draw front view and top view of a particular object. So let us start the lecture. So over here one problem is given to us and statement is draw front view and top view in first angle of projection. So one image is given to us and we have to draw the front view and top view of the object shown in this image. And we are asked to draw these two views in first angle of projection. So that means we have to consider that object is in the first quadrant and accordingly we have to construct both the views. And we know that in first angle of projection we draw front view above reference line and top view below reference line. So that pattern we have to follow in order to answer this particular question. So let us see what steps we need in order to draw these two views of this particular object. Now you will be given an object and you will be asked to draw the different views of that object in any particular angle of projection. And in that view or in that picture no planes will be labeled, means they will not show you the position of vertical plane or the horizontal plane. So you have to decide the position of those two planes depending upon the angle of projection given in the question. Now in this question he is saying that we have to plot these two views in first angle of projection. Then you should think the sequence in first angle of projection. In the lecture of quadrant system, we have learned that the sequence in first angle of projection is first we have observer, then we have object, then plane of projection is behind the object. So in this case, if we are looking at this object from this side, then we have to satisfy the same sequence. That means we have observer, then we have object, then we have to assume that vertical plane is behind the object. Similarly, when we will look at this object from top, then again we have to satisfy same sequence. Observer, object, then we will assume that plane of projection is below the object. That means horizontal plane is below the object. So in this question, horizontal and vertical planes are not given to us. So depending upon the angle of projection mentioned in the question, we have to assume position of vertical plane and horizontal plane of our cone. So in this case, we have observed that we are given first angle of projection. That means we should consider vertical plane behind the object and horizontal plane below the object, because we have to keep the object in the first quadrant. So this is the very first thing we have to keep in our mind before solving any problem on orthographic projections. Now after that, we have to see that which side of the object given in the picture is marked as the front. Now if you see this question over here, we are given one arrowhead and it is marked as front. It means when we have to draw its two views, front view and top view, we have to read this object from this side only. Means we have to place the observer this side and we will consider this side as front side of the object. So if we have considered this side as the front side, it means observer's left will be left of the object, observer's right will be right side of the object. And we know that whenever we draw projections of an object, we don't rotate the object, we don't change the orientation of the object. If we have to draw the front view of the object, we look at the object from front. If we have to draw the top view of the object, we will look at the object from top, but we will maintain this direction. Means if I have to look at this object from top, we have to maintain this direction and we will look from top. Okay. Now in this case, one more important observation we have to make before the start of the answer. That observation is related to the dimensions of this object. Now we have learned that this is the front side of the object and observer is standing this side and observer is looking at the object. Now we have to identify three dimensions of the object carefully. We know that this object has length, width and height. So let us see that if observer is looking at this object from this side, then which dimension will be the length dimension? Now when observer looks at the object from front side, any dimension moving from left to right of the observer will be considered as length dimension. You can see this dimension is moving from left to right of the observer. So for observer, this dimension will be length dimension. Similarly, any dimension moving in upward direction for observer, that will be the height of the object. And any dimension in the object moving away from observer will be considered as width of the object. Now you can see this dimension. This dimension is moving away from the observer, moving away from the observer. So this is width of the object. So this should be very clear to you that whenever observer look at any particular object, then any dimension from left to right of the observer will be length of the object. Any dimension in our direction is the height of the object, and any dimension moving away from the observer is width of the object. Okay, so this should be clear to you. Now we will start with the front view of this object first. Now, if you can recall the previous lecture in which we have discussed that when we look at any object, we can see only two faces. The faces which are parallel to the reference plane or the faces which are inclined to reference plane. The faces which are perpendicular to reference plane will not be visible to the observer because those faces will be like a line for the observer. It means if I have to draw the front view of this object, then I have to search two kinds of faces which are either parallel to VP or inclined to VP, because when observer will look at this object from front, then observer will project the image on vertical plane only, which is behind the object. So it means we have to search for those faces which are either parallel to VP or inclined to VP in this particular object, because observer can see only those two kinds of faces. The faces which are perpendicular to the plane of projection will not be visible to the observer. Okay, so it means now first step is we should see how many total number of faces are there in this object. So over here 8 faces are marked. Apart from these 8 faces, we have left side face, we have rear face and we have bottom face. But you can see bottom face, left side face, these two faces are perpendicular to plane of projection. So we will not consider these two planes. And the rear face is covered by the front faces. So there is no need to consider rear face as well. It means we are left with these 8 faces which are visible to us in this 3D image of the object. So first step is see how many total number of faces are visible to us in the 3D image given to us. Then out of those faces we should see how many are parallel to VP and how many are inclined to VP. Remember, VP is behind the object. So if you will see carefully, you will find out of these 8 faces, only 2 faces are there which are actually parallel to VP. So this is face number 1 and face number 2. And apart from these 2 faces, there is no other face parallel to VP. So we have concluded that in this object there are 2 parallel faces. So observer can see these 2 faces from front. Now let us see how many faces are there which are inclined to VP. You can see there is no face over here inclined to VP. It means we have concluded that in this object we just have to draw two faces only, face number 1 and face number 2. If we will draw these two faces in their proper dimension and proper location with respect to each other, then we will get the front view of the object. So with this fundamental, we will work for the front view. Now, if you are confused that when we look from front, all the faces are visible to me, some students think like this. If you are confused how to pick the parallel faces, then let me give you a thumb rule over here. Now, when we look at any object from front side, remember we can only see two dimensions. We can see length of the object, we can see height of the object. From front side, you cannot see width of the object. It means from front side we can see only those faces in which we have length dimensions or height dimensions. Now let us apply this thumb rule to these two faces observed by us. Let us apply it to the first face. Now if you see the dimensions of first face, all dimensions are either length dimensions or height dimensions. Means in face number 1 there is no dimension moving away from the observer. It means in face number 1 we don't have width dimension. It means this face will be visible to the observer. Similarly, if you will see face 2, in face 2 again either we have length dimension or we have height dimension. There is no width dimension. It means face 2 will also be visible to the observer. But if you will see other faces, let us pick face number 5. In face number 5, we have length dimension, but we have width dimension also. So remember, any face having width dimension will not be visible to the observer from front side. So you can see the case with face number 3 also. Same case. It has height dimension plus it has width dimension moving away from observer. Similarly in face number 4, width dimension moving away. Face number 6, width dimension moving away. Similarly with 7 and 8th face. So we have concluded that if we are looking at the object from front side, we can see those faces in which there is no width dimension. Or we can say we can see only those faces which are either parallel to HP or inclined to HP. So moreover we can say about these faces which we don't see from front, we can say that these faces 5, 3, 4, 6, 7, 8, these are perpendicular to plane of projection. That is perpendicular to VP. That is why these are not visible from front. Okay. So now we have concluded that if I have to draw front view of this object, then I have to draw face number 1, face number 2 with their proper dimensions and proper location. So out of these two faces, we will pick that face first which is closer to HP. So where is HP? HP is below the object. So out of face number 1 and face number 2, face number 1 is closer to HP. So let us start with face number 1. We will plot this face first. Now how to plot? We will first see how many points are there on that face. So you can see there are how many? 3, 4, 5, 6, 7, 8. There are 8 points on this face. Then out of these 8 points, we will pick the lowest point. Let us pick the lowest left corner of this face. So this is the lower left corner. So let us pick this point and mark that point on the paper. Now from this point, we will start the drawing of this face. So we are looking from this side, remember. Then if I have to move to this point from that point which is marked on the grid sheet, then how much we have to travel towards right side? We have to travel 60 millimeters. It means from this point I will sketch a line of 60 millimeters. So we have reached to this point. Now from this point I have to move in upward direction to reach to this point by how much? It is mentioned over here as 10 millimeters. Then from this point I will draw a vertical line of 10 millimeters with the help of scale. Now we have reached to this point. Now we have to move to this point. It means how many units we have to travel towards left side? Now how many units? It will be 60 minus 40. So it will be how much? It will be 20 millimeters. It means from this point now we'll move towards left by 20 millimeters. So we will draw a line of 20 millimeters. And remember, we are drawing the view of the object. It means all the lines must be continuous thick lines. So we have reached up to this point. Now we have to reach to this point. Then how many units we have to move in our direction? So this distance we have to find. Total height of the object is 40 millimeters minus this height minus this height. So 40 minus 10 minus 10. So this will be 20. It means from this point we will draw a continuous thick vertical line of 20 millimeters. Then we have reached at this point. Now in order to complete this phase 1, we have to move towards left by how much? By 20 millimeters. It means from this point we will draw a thick line of 20 millimeters. Now we have to move in upward direction by 10 millimeters. So from this point draw a thick line of 10 millimeters. We have reached at this point. Now move towards left again by how much? By 40 minus 20 by 20 millimeters. So from this point draw a continuous thick line towards left of 20 millimeters. Now we have reached to this point. So now in order to reach to the starting point we have to connect these two with a vertical line of 40 millimeters. So when you will draw a line from this point to reach up to this point, you will find that this is 40 millimeters. So now you can see we have drawn the drawing of phase 1. Now in order to get the front view of this object, we have to draw the second phase also with the proper location and dimension. Fine. It means first of all we should locate this phase 2 with respect to phase 1. So what is the procedure? Procedure is, again you should see how many points are there on second phase. So you can see this phase consists of 3 corners, or you can say 3 points. Now in order to locate this point with respect to first phase, we will pick any one point. So let us pick this point of that phase. Then locate that point in phase number 1. Remember, we are looking from this side, from front. So you can see this point of phase 2 is exactly behind this point. And this point belongs to phase 1. And this point in the front view is over here. It means from this point I can start phase number 2. So we have located phase number 2 with respect to phase 1. So right now we are at this point, So in order to draw phase 2, what we have to do, from this point we have to draw a thick line towards right, and that line will be of 20 millimeters. So from this point we will draw a thick line of 20 millimeters towards right. So we have reached to this point. Now we have to reach up to this point. It means we have to travel how much in downward direction? 10 millimeters. So from this point we have to draw a thick line of 10 millimeters in downward direction. Now you can see over here that this edge of phase 2 is exactly behind this edge of phase 1. We can say this edge of phase 2 is covered by this edge of phase 1. So no need to draw this. It is already there in the drawing of phase 1. Similarly, this edge of phase 2 is exactly behind this edge of phase 1. So it is already drawn in the drawing. So no need to repeat this edge again. So you can see we are ready with phase 2 also. So this total is called as front view of this given object. So I hope the fundamentals of drawing the front view of an object are clear to you. Now let us move on to top view. Let us see how we have to construct top view. Now in order to construct top view, the very first step is that we should draw a reference line. And the position of the reference line will depend upon in which angle of projection we are drawing. You can see we are drawing in first angle of projection. And we know in first angle of projection we keep front view above reference line. It means after drawing front view we need to draw a reference line below it. Now next question comes that how much distance we should keep between the projection and the reference line. When you are solving problems of orthographic projections, then in these problems this distance will not be given to you in the statement. You are simply asked to draw front view and top view. So this distance you can keep any distance. So this distance is your choice. So normally leave one row gap of 10 millimeters or two row gap of 20 millimeters and draw the reference line. And label that reference line as capital X and capital Y. And after this, what we will do, from all the points of the front view, we will draw continuous thick lines in downward direction. These lines will be parallel to each other and perpendicular to the reference line. These are called as projectors or projection lines. So these must be continuous thin. These projectors will help us to draw the top view that we will see shortly. Okay, so you can see these 2 points are on one line, so we got only one projector. Similarly, these 2 points are on one line, we got one projector. Similarly, these 3 points are on one line, so we got one projector only. So similar is the case for these 2 points. Now in order to get its top view, observer has to change his position, but he has to maintain same direction. Means maintain same direction, but now look from top. So when observer will look at the object from top, then again he will search for those faces which are either parallel to plane of projection or inclined to plane of projection, because observer can see only these two kinds of planes. And when observer is looking at the object from top, then in that case plane of projection will be horizontal plane. And horizontal plane in first angle of projection lies below the object. So we have to assume that horizontal plane is below the object. So again rule over here is same, that now we have to search how many total number of faces are there. So again same number of faces are there. Now out of these faces we have to pick how many are parallel to HP. So you can see face number 5, face number 4 and face number 7 are parallel to HP. And apart from these three faces, there are no other faces parallel to HP. Now let us see how many are inclined to HP. And you will find that there is no face inclined to HP. It means we have concluded that we have to draw only these three faces with their proper dimension and location in order to get the top view of this object. Okay, if you are confused that how to pick parallel faces or inclined faces or the faces which will be visible from a particular direction or from top, let us say in this case, then what to do? Suppose I am confused when I am looking at the object from top and it seems that these faces are also visible to me. So how to get rid of that confusion? Let me give you one thumb rule here. Now when we look at any object from top, we can see only two dimensions. Length dimension or width dimension. Remember, we have maintained this direction while looking from top. So this is width dimension for us. This is length dimension for us. When we look at any object from top, we can't see height of the object. So it means we concluded we can see only those faces from top in which there is either length dimension or width dimension. Now let us apply this thumb rule to these three faces. Let us start with face 5. You see, remember, I'm again recalling that direction is this. We are looking from this direction, but we are looking now from top. We have maintained this direction, we are looking from top. So this is length dimension, this is width dimension. So in face number 5, there is no height dimension. It means this face will be visible from top. Similarly, in face number 4, there is either length dimension or width dimension. So it will also be visible from top. Then face number 7, there is length dimension and width dimension. So this will also be visible from top. But if we talk about other faces, face number 1, in this face there is height dimension. So this is not visible from top. In face number 3, there is height dimension, not visible from top. Face 2, face 6, face 8, height dimension, height dimension, height dimension. So these are not visible from top. So we concluded that there are only 3 faces which will be visible from top. It means if we will draw the drawings of these 3 faces with their proper dimension and location, we will get the top view of this object. Okay, so out of these 3 faces, we have to pick that face first which is close to VP. Remember, when we were drawing the front view, we said pick that face first which is close to HP. So why we said that? Because we were drawing above reference line. Means we were drawing above HP. But now when we have to draw the top view, we are saying pick that face which is close to VP. Why close to VP? Because we are now drawing below reference line. So close to VP means close to reference line. So we will pick that face first which is close to VP. Now you can see face number 5, this edge, and face number 7, this edge. Both are at same distance from VP. So either we can start with face 5 or we can start with face 7. It is our choice. So let us start with face 5. Now how to draw this face 5? Again rules are same. See how many points are there on that face. So there are 6 points. Out of these 6 points, pick that point first which is close to VP. Remember, while drawing the front view, we said pick that point first which is close to HP. So we picked lower left corner. But now while drawing front view, as we are drawing below reference line, so we will say pick that point first which is close to VP. So there are 2 points close to VP. So we can pick any one out of these 2. So let us pick this point. And after that, we have to see the location of that point in the front view in order to select correct projector or in order to select its location below the reference line. So let us locate this point in the front view. Where is front? Front is this side. So this point is exactly behind this point. And this point in the front view is over here. It means the projector which is coming from that point, we have to select that projector. So again I am repeating, we have to pick that point of the first face which is close to VP. There were 2 points, so we picked this one. Then we have to locate that point in the front view. So this side is the front. So move towards front from that point. So if you will move towards front from that point, you will come to this point. And this point in the front view is over here. So we have to select that projector which is coming from that point. It means we will mark this point on this projector. Now we will start the drawing of face 5 from this point. So right now we are at this point and direction is this and we are looking from top. So in order to reach to this point, how many units I have to cover towards right? 40 millimeters. So from this point, I will sketch a continuous thick line of 40 millimeters. It will exactly stop up to this projector. Fine. Why it has stopped up to this projector? Because this projector is coming from this edge and that edge is actually this one. Fine. So you can see this line over here actually consists of these two edges, which are the edges of face number 5. Fine. It means this edge is the front view of face 5. I hope this point is clear to you. Okay. So now we have reached up to this point and now we are looking from top. So how many units we have to move towards ourselves, or you can say in downward direction? This is how much? This is 40 minus 20. So this is 20. So from this point, we will move 20 millimeters along this projector in downward direction. So we have reached up to this point. After that, we have to move towards left by 20 millimeters. So from here, we have to move towards left by 20 millimeters. Then from this point, if I have to move to this point, I have to move in downward direction by 20 millimeters. So from this point, draw a continuous thick line of 20 millimeters. Now we have reached at this point. In order to reach to that point, we have to move towards left by how much? By 40 minus 20, that is 20 millimeters. So when you will draw a line of 20 millimeters, it will exactly stop at that projector. Then in order to draw this edge, we have to draw a vertical line of 40 millimeters in upward direction. So in upward direction, 40 millimeters. So we are ready with the drawing of phase 5. Now let us pick the next phase. The next phase is phase number 4. So how to draw phase number 4? For that, first of all, we have to locate phase number 4 with respect to the first phase drawn by us, that is phase 5. So for that, what we need to do, we need to see how many points are there on that phase. So how many points are there? There are 4 points. So out of these 4 points, we can use one point and locate it with respect to first phase drawn by us. So if I pick this point, you can see this point is just below this one because we have to move towards the first phase. So from this point, when you will move towards the first phase, that is phase 5, then you will reach up to this point. And this point on phase 5 is here. So it means from this point, we will start the drawing of phase 4. So right now we are at this point and we have to move towards this point to complete phase 4. And how much is this length? It is 20 millimeters. So from this point we have to draw a continuous thick line of 20 millimeters towards right. Then we have reached at this point. Now we have to draw a vertical line in our direction of 20 millimeters. So from here, draw vertical line of 20 millimeters. Now you can see phase number 4 is ready. There is no need to draw these two edges of phase 4. Why? Because this edge of phase 4 is just below this edge of phase 5, which is already drawn in the drawing. Similarly, this edge of phase 4 is just below this edge of phase 5, which is already drawn. So you can see we are ready with the drawing of phase 4 also. Now over here, let us make very important observation. But if you will look at this phase 4 from front side, what you will see? You will see its front as an edge. Because from front this face is perpendicular to VP. So we have drawn that face over here. If I take projections of this face, see from this end we have taken one projection and from this end we have taken another projection, and these two projections will lead us to a line over here. So this line is what? This line is front view of phase 4. That is this edge. Now you can relate this with projections of points chapter. In that chapter or in projections of line chapter, we were saying that top view of a point is exactly below front view of a point, or front view of a point is exactly above its top. Now you can see that top view of phase 4 is exactly below its front view. So you can see how these projections or projectors are helping us to draw the views. Okay, now let us move to the last phase. So how to plot that phase? Rules are again same. Now see how many points are there on that phase. There are 4 points. Out of these 4 points, pick any one point and locate that point either with respect to phase 4 or with respect to phase 5. It's your choice. So let us pick this point. So and move towards these two faces. So in order to move towards these two faces, we have to move in upward direction. So if I move in upward direction from this point, means along this edge, I will reach to this point, and this point belongs to phase 5. So we can say this point of phase 7 is lying below this point of phase 5. So that point is where? That point is here in the top view. Fine, because this corner belongs to phase 5. So from this point, how many units towards right side? It will be 60 minus 40, that is 20 millimeters. So from here I will draw a line of 20 millimeters. And you will see it will exactly stop up to this projector. Then from this point, in order to reach to this point, we have to draw a vertical line of 40 millimeters in downward direction, means towards observer. Observer is here, this side. So from this point, draw a vertical line towards observer of 40 millimeters. Then draw a line up to that point and it will be again of 20 millimeters. Now there is no need to draw this edge, means there is no need to draw this edge. Why? Because this edge is covered by this edge of phase 5 and this edge of phase 4 from top, and these two edges were already drawn. Now you can see we are ready with the top view of this particular object. So I hope all the fundamentals of drawing front view and top view of an object are clear to you. But over here, let us make one more important observation. If you see this face, that is face number 7, if I project this face in our direction, follow these projections. These projections will lead you to this edge or this line. So this is front view of this face. You can see this edge is over here. Fine. So like this you can relate the front and top of a particular plane. This will help you to find that whether your front and top are correct or not. Okay, we are done with the projections. Now it's time to place dimensions. Okay, now let us see how to place dimensions. Remember, whenever you have to start dimensioning, you should place 3 important dimensions first. You have to show complete height of the object, complete length of the object, and complete width of the object. And let us observe these two views carefully. We know that when we look at the object from front, we only see length and height dimensions. So in the front view, there will be only 2 kinds of dimensions, length dimensions and height dimensions. But we know when we look at object from top, we see length dimensions and width dimensions. So in the top view, we only see length dimensions and width dimensions. So remember, this is height because it is front. This is width because this is top. And this is length and this is also length. So length is visible in both the views, but in the front view, along with length, height is visible. In the top view, along with length, width is visible. So let us first place height of the object. So how much is the height? Height is 40. So from these 2 points, draw continuous thin lines by leaving 1 millimeter gap and draw a dimension line after leaving 10 millimeters gap. From object line, place close filled arrowheads on both sides. Arrowheads must touch the extension line and you can follow any system of dimensioning. Over here I am following aligned system, means vertical dimensions are readable from right side of the page. After that, let us place its width. So how much is width? Width is 40. So width is visible here. So it means from these 2 points, we will draw continuous thin lines after leaving 1 millimeter gap. And from object line, leave 10 millimeter gap and draw dimension line. So this is the width of the object. Now let us place its complete length. So how much is the length? 60. So that we can place over here. So from these 2 points, draw continuous thin lines and place dimension line. That will be 10 millimeters from this object line. So that is 60 millimeters. Now after placing these three dimensions, that is complete length, complete height, complete width, we will place the remaining dimensions given in this diagram. So let us first place remaining height dimensions. So how many height dimensions are left? We have placed 40. Now next height dimension is 10 millimeters here and 10 millimeters here. So let us place these two dimensions. So over here, from these 2 points, we'll draw continuous thin lines and we'll place 10 millimeters. Then from these 2 points, we'll draw continuous thin lines and we'll place 10 millimeters. So now we are done with all the height dimensions. Now we'll see how many length dimensions are left. We have already placed 60. So apart from 60, there are two more length dimensions, 20 and 40. So let us place 20 millimeters first. So from these two endpoints, let us place 20 millimeters. Okay. So after placing 20 millimeters over here, we can skip 40 millimeters. Why? Because if we subtract 60 minus 20 and divide by 2, then each dimension over here will be 20 millimeters. So we can skip that dimension. Now after that, we have to place width dimensions. How many remaining width dimensions? We have placed this one, total width, now we are left with only 20. So from this point, from the view, after leaving 1 millimeter gap, we will draw continuous thin line from the view. Continuous thin line after leaving 1 millimeter gap from that point. Then we will draw dimension. So now you can see we are ready with the dimensioning also. So I hope now the procedure of drawing front view and top view of any object in the first angle of projection method is clear to you. Thank you very much.